So today we are going to see architecture of 8051. This is your architecture diagram. So you look at the diagram. Here architecture of 8051 microcontroller have uh, accumulator B register, okay, which is used for getting the data. Okay, getting the input data which have to perform the operation, any operation. Actually, that data will be available in the B register as well as accumulator. Okay, then this is temporary one and temporary two register. So temporary two register will hold the data which going to perform the arithmetic logic operation. ALU unit in the ALU unit. ALU arithmetic logic unit, which will be the performance of addition, subtraction, multiplication, add or and okay. Everything will be done in the ALU unit. And then temporary register 1 will get the data or mnemonics. We get the mnemonics. Mnemonics is nothing but your operation. Okay. Assembly language programming will be received by the temporary register 1. Okay. And then here RAM address register. So random access memory address register. So it will hold the address, current address of the executing program. Okay, and then RAM, random access memory, and then port 0 latch. Here you will be having four latches, that is port 0, port 1, port 2, port 3. So the violet color வந்து four ports. It is port 0, port 1, port 2, port 3 latches. So the corresponding 1 minute. So the violet color will show you the ports, that is port 0, port 1, port 2 and port 3. Latches. Latches I think you all know. Temporary storage device, which will be having separate drivers for their port. Okay. So port 0 driver, port 2 driver, and then port 1 driver, port 3 driver. Okay. So independent drivers will be available for each ports. Latch and driver will be individual for each and every port. So totally 4 ports will be available here. So port is nothing but input out to connect the input output device to the port. Okay. For that only you will be having the 4 ports. And then stack pointer. Uh, I think you all know stack memory. It is nothing but whatever the first in, first out. Okay, so which will be having the first in will be taken as the last memory. Okay, last memory location. That will be called as a stack pointer. So here stack pointer is used to hold the address of your stack memory. Okay. And then ROM, that is read only memory, which will hold the programs. So RAM is used for storing the data. Here ROM is used for storing the programs. So program address register. Okay. So the program given data order address will be stored in the RAM address register. So program address will be stored in the program address register. Okay. And then buffer is a temporary storage device. Then PC increment, that is, it will be used for incrementing the data. Okay. And then program counter. Program counter is a 16-bit address folder which will hold the current address of the program. Then DPTR, data pointer. Okay. DPTR stands for data pointer. And then here oscillator. Oscillator will generate the clock signal, which make the every units to work simultaneously. Okay, by providing the clock signal. Here, crystal oscillator will be used here. That is represented in the diagram. And then time and control. So time and control will provide the timing and control on the blocks present in the architecture. Then here it will provide the force signal, RST reset signal. This is enable access. E in the enable access. ALE address latch enable. PSEN program status word enable. Okay. And this is VCC plus VCC VSS power supply. Okay, positive supply and ground. So four ports available. So each and every port will have 8 pins. Okay, P0.0 to P0.7. Okay, so 0 port have 0 to 7 pins. Similarly, we'll be having for port 1, port 2 and port 3. So each port will have 8 pins. So each and every block will be learned directly. Now first central processor unit. So CPU. So I think you all know CPU. CPU is the brain of any processing device of the microcontroller. It monitors and controls all the operation which is going to be performed in the microcontroller unit. The user has no control over the work of CPU directly. Here it reads program written in the read-only memory. So already I said you read-only memory will hold the programs. Okay, so that program will be executed and the expected task will be performed by your CPU. Okay, then interrupt. So interrupt is a subroutine call. Okay, some small task which will be called in between the main task. Okay. Subroutine call that interrupts the microcontroller main operation at work and causes it to execute any other program, which is more important at the time of operation. Okay. The feature of interrupt is very useful as it helps in case of emergency operation. So interrupt is done during the main process. Okay. At emergency cases and also gives a mechanism to put on hold the ongoing operation execute a subroutine, and then again switch to another type of operation. That is nothing but on doing the main program, the interrupt system will be interrupt the main program to do the uh, subroutine call this subroutine program, and then after executing that subroutine program, again it will resume the main program. Okay, is given in this paragraph. And then the microcontroller 8051 can be configured in such a way that it temporarily terminates or pause the main program at the occurrence of interrupts. When a subroutine is completed, then execution of main program starts. Okay. Then memory device. So here memory device. What are the memory device used in the microcontroller? I'm saying picture. You can say what are the memory device used here? Anyone say it? Any one of you say what are the memory device used here? What are the registers used here? படத்தை பார்த்து சொல்லுங்க. மியூச்சுவலா கம்யூனிகேட் பண்ணுங்கம்மா. சிம்பிள் கொஸ்டின் தானே கேட்குறேன். ரொம்ப காம்ப்ளிகேட்டடா கேட்டா கூட பரவாயில்ல. ஓகே ஃபைன். அப்படியே ஆன்சர் பண்ணாதீங்க. அப்படியே So here microcontroller requires a program which is a collection of instructions. So program is nothing but collection of instructions. Okay. So all the instructions together will be designed for a designing a program. This program tells microcontroller to do specific task. ஒரு task perform பண்ண you will be designing a program. This program require a memory. Okay. On which these can be saved and read by microcontroller to perform specific operation of a particular task. Okay, so memory is needed for saving the data as well as the programs. Okay, your instructions for doing a particular specific task. Okay, the memory which is used to store the program of the microcontroller will be called as a program memory, otherwise code memory. Okay, it is known as read-only memory of microcontroller. Otherwise, we can call the program memory as read-only memory. Okay, so ROM is used for storing the program. RAM, that is RAM device, is used for storing the data. Okay, so the data memory of 8051 is used to store the data temporarily. That is nothing but RAM memory. Okay, so the size of the program memory will be 4K, 4 kilobytes. Okay, so that you will be able to access 128 bytes of data will be stored in the RAM memory. Okay, data memory have 128 bytes, and then read-only memory will have 4 kilobytes size. Okay, this is the memory, and then bus. So what is bus? Bus is nothing but collection of wires will be called as a bus. Bus is used for communication between the microprocessor with all the blocks as well as external device. Okay, transfer data or address or control signal will be transferred through the bus. So buses will have three types, that is data bus, address bus, and control bus. So here these bus consist of 8, 60 or more wires of the microcontroller. Thus, these can carry 8 bits, 16 bits simultaneously. Here, two types of buses are shown in below, that is address bus and data bus. So address bus will transfer the address 16 bit address. Um, Here it is used to address memory location and to transfer the address from CPU as well as from memory to microcontroller. Okay, here four types of addressing modes are used in the accessing address, accessing of data, that is immediate addressing mode, and then bank address, or otherwise we can call it as register addressing mode, direct addressing mode, and then register indirect addressing mode. So immediate addressing mode, immediately your address will be available in the index, that is in instance. Bank address or register addressing mode is nothing but you will be giving register. Okay, through the register it will be addressed in the instruction. Direct addressing mode means directly it will access the memory by addressing in the instruction. Okay, directly it will be provided in the instruction. The register indirect addressing mode means your address will be indirectly represented in the instruction. That will be called as a register indirect addressing mode. Addressing mode will be seen later. Elaborately, we will be seeing about the addressing modes. Then data bus. So data bus is used to transfer the data. Okay, um, this is 8-bit data bus, and then oscillator. So oscillator is nothing but it will generate the clock pulses. Okay, for doing the operation. So for this purpose, microcontroller 8051 has an on-chip oscillator which works as a clock source for central processing unit of the microcontroller. The output pulses of oscillator are stable, therefore it enables synchronized work of all the parts of your 8051 microcontroller. Simply we can say it, oscillator will generate the clock pulses which make the all the parts of microcontroller to work simultaneously or in synchronized form. Okay. The next, input output port. So here the ports, four ports are used. Okay, four input and output ports are used. Here each and every port will have latches, separate latches and drivers. Okay, latches is nothing but storing device which will store the data or data which is going to be transferred or received. Okay, through the ports, and then drivers which will drive your input and output ports. So through the input output port only you will be connecting to the external device. Okay, with the microcontroller. The next, timer or counter. So here you will be using two 16-bit timer and counter. So here these counters are divided into two 8-bit register. Okay, so 16-bit counter can be used as a two 8-bit register. Your timers are used for measurement of intervals to determine the pulse width of your pulses. So this is your architecture of 8051. Then applications of 8051 microcontroller. What are the applications? ஏதாவது தெரியுமா applications? So day to day life, we are using many microcontroller device. For example, your fridge, washing machine, everything is designed with using microcontroller only. Okay, everyday use. Simple example for application of microcontroller is your washing machine. Okay, then வேற என்ன இருக்கு நிறைய okay, எல்லாமே பார்த்தீங்கன்னா மைக்ரோ கண்ட்ரோலர் பேஸ்ட் தான். So few examples are given here. They are light sensing and controlling devices, temperature sensing and controlling device, sensor, fire detection and safety devices, automobile application, defense application, defense na உங்களுக்கு தெரியும், military, industrial applications, and then industrial instrumentation devices, process control devices, measurement device, voltmeter, மாதிரி measuring devices, and then handheld metering system, current meter object. Okay, so in all the field, your microcontroller is applicable. So tomorrow we will see the next topic. So in the architecture of 8051, do you have any doubt?